Thank you very much for the opportunity to speak to you today. I would like to share my experience and while working in a banking industry, which is highly regulated. Four main points: choice of programming language. I will be discussing why and how you choose the programming language. The current tools and objectives in particular in risk modeling and applied in a commercial banks that is highly regulated and require disclosure and so on. So it's not so straightforward using open source software. The next point, it's the trends emerging behind interest of end users, actually calling for change. That is somehow different as many years ago, that the industry dictated the choice, but now it's coming from the end user. And in the future, envision widespread uses of R in modeling, in particular statistics and in risk in particular in this case. My intention was to start with the question how you encountered or you made a choice for programming language, whether it was first open source or commercial. But I would infer that it was indeed for the younger population it was the open source that is easier to acquire. So first was required at work, conditional obtaining job, started learning at work. Was this or the natural choice that you have tools available and you pick it up? In banking, in risk management, there is adequate tools that are needed to target the particular needs. This required flexibility of usage and so on. Historically, still widely used commercial language is the SAS. There is next presenter, 1035, will be discussing approximately the same topic. If you don't know SAS, it's good for you. If you do know, then try to forget it. These advantages, disadvantages, many. The limited sharing materials, particularly non-existent community. There's problem with transparency of the implementations, reviewing source code, and so on. It's not there. Increase lower candidates availability for hiring and so on. So the main point of this presentation is that it's changing how the statistical or the programming language is picked, and it's mainly driven by the end users as the main force. The job market increasingly favors the alternatives. Much harder is today to recruit or find people that are willing to work in the particular language, and is driven vice versa by the industry that it's willing to find the needed people for the job, and is willing to change the software that accommodates the interest of the people. Very useful to use R as is a prototyping, the fast implementation, improved first versioning, availability of the packages. I would say it's the main point. It's the availability of sources of information, books, and so on that drives know-how and sharing and so on that increase the knowledge and actually the output. There's no time for questions. I ran up the slides, so maybe if you want to approach me later on for.
Thank you very much.
Thank you.
I'm very sorry, the nanny is not here, so I'm Christophe and she's Ariane, and we're going to I'm going to present you R++, a new graphical user interface for R. She's not impressed. She already gave talk for 200 students when she was in the not born yet. So to introduce R++, I need to first speak about a science called human-computer interaction. Human-computer interaction is a science whose goal is to simplify the interaction between human and computer. How does it work? You take 5 data scientists or 5 statisticians, you put them in a room and you ask them, what's wrong with your current software? We do not speak about R, we speak about R, SPSS, SAS, data, everything. What's wrong in your current software? 1 hour of brainstorming. So the brainstorming, we take one main idea, or 2 or 3, and we ask people to think about that. Mainly, we say, okay, you're walking on a beach, and you find a lamp. You rub the lamp, and that's your lucky day. A fairy comes out. Unfortunately, this is a fairy of statistical analysis. So you get yourself 3 wishes, but 3 wishes that will work only in the statistical analysis field. What will be the 3 wishes? How will work the perfect statistical analysis software of your dream? That's a 2nd hour of brainstorming. And the 3rd hour, we make what we call some low-resolution protocol. That's it. We take a piece of paper, we take scissors, we take Post-it, and we make a movie on how should work the ideas that I just have. So we see that there is an arrow, this is the mouse, and I will click here and it will open, things like that. And that's how we start R++. We make something like 20 meetings, that's 150 video, and we take the idea of all the video and we start building R++. So because of the timing, I will not make you a demo, but I will tease you at least a little bit. The major thing is data management. That's the nightmare of many. I mean, you people, you are highly educated people, you know how to make nested analysis and random forest, and you spend between 30 and 50% of your time trying to find abnormal value. That's just not fair. So that was the main things. And a solution for that is we add a button. When you press it, we have a graph on each column. So it's very easy at a glance. Statisticians like you will notice as immediately that there is something wrong in age, probably an abnormal value. There is something wrong in sex, because there is 3 modalities instead of 2. Second, editor always asks me to change DP. I never know how to do it. How many people like you know how to change canal alpha or to suppress canal alpha? You have 2 seconds more. Okay, you don't know. And when you send some graph to editors, they say, okay, your graph is nice, but remove canal alpha and change DPI. So we provide a graphical interface who change graphic. And you can do everything by just clicking, changing color, changing text, adding some shape, suppressing canal alpha and things like that. And then when you're done, you take the graph, you drag and drop it in Excel, Word, or OpenOffice, or email. I work with many files from many companies. I spend a lot of time to open them. When you're working with CSV, comma separated value, for example, in French, we don't use the comma to separate the colon. We are French. So we provide an interface that is in which you will have a preview of your data. So it will be very easy on this one to see that if you use the comma separated value, it will work or not. You can change the encoding, you can change many, many things, and you have immediate feedback. And the last, but not the least, we statisticians need code. We need access to all the possible techniques. We need code because I want to send my code to the Food and Drug Administration or to my boss or to many people. And I want to use the very new package that some Japanese, or because Japan is far from me, just put on the CRAN thanks to him yesterday. So we provide that's too long. We provide our console inside, so you can also use your package and everything that you used to be. That's it. Just to finish, because many people ask me, we are not our competitor, we are not our studio competitor. We are between Excel and R. We are for people who are not statisticians, like medical doctor, web marketing, communication people. They have a job, and in addition, they make some statistics. We are for them. Bye-bye.
Hi, I'm Kieran Martin. I'm from Roche, statistical program there. Look at all those extra seconds I've got. So I'm going to talk today about a work I did in collaboration with Craig Gower at Rush. Rush is basically full of SAS programmers. It's the kind of the language of choice there, certainly for producing our outputs to health authorities like the FDA and the EMEA. All our work's done in SAS. There's a minority of us that love R and want people to use R more. Hopefully I don't have to convince this audience that R is a nice language to use. But I do have to convince people who've been programming SAS for maybe 10 or 20 years and don't really see the incentive to change. So we started thinking about how we might solve this problem. And there's lots of approaches we're taking. I've got 5 minutes. I'm going to talk about 2 of them. The first is tailored training. So we'd had some in-house, some external R training before, but it was often quite generic about the R language, and it didn't relate to the actual work that people were doing. So what we did was create tailored training that was based on our internal data and the kind of problems people have to face every day. And we showed how you could solve those primarily using the tidyverse, which means it was syntax that was fairly friendly and easy to use and quite familiar for people who were used to SQL as well. On top of that, we added some ideas, some more R-centric ideas for transitioning from SAS to R, so thinking around ideas around functional programming, unit testing and assertions, which weren't really used and still aren't used that much. And we had a lot of success with that. But on top of that, to help people transition, we wanted to create packages. So our packages are great. Again, I don't think I need to sell that to this audience, but they're really great, even small packages that solve small problems. So a lot of the packages we create just do one thing and do it really well, and they're just internal and just used to go through a problem that people face in their day-to-day. However, we are trying to open source where possible. I'm going to talk about one package for the rest of this talk called diffdf. So this package myself and Craig made, it's on CRAN, there's a GitHub link there, you can go and check out and find out more about it. It's a package that allows you to compare 2 data sets which are meant to be identical and basically picks out all the differences in a nice way. There are tools that do this in R, but they weren't quite what we wanted, because what we wanted was a really nice breakdown of all the differences and to pick out every kind of difference you can think of between 2 data sets in R. So I'll show you an example of what that looks like. diffdf is a pretty small package in terms of the number of functions exposed. The main one is called diffdf, imaginatively. And you give it the base data set, the comparison data set, and any keys you want to match on. There's some additional arguments, which I'm not going to worry about today, that sort of control how the output looks. So if I move into an example here where I've got some data and I've just set one value to missing, you can see that when I run diffdf, it gives me some warnings and it'll warn you for any issues it finds. You can turn that behavior off if you don't want it to fill up your console with warnings. If we examine the object that's created there, we'll see that only the differences that it spotted were captured, and then it breaks those down into different objects. And those are captured pretty much always as tibbles because they're just really nice. They print nicely, and they can also hold list columns, which are really useful for when we're looking at attributes. So obviously when we compare columns in R, we're not just interested in the values of the columns, we're also interested in any attributes it's holding. So diffdf will pick those out. In this example, I've changed the label of a column, but it'll pick out any arbitrary attribute and determine whether it's different or not. So it's obviously useful in the case of factors, if you've got a bonus level hanging around in one column, which wouldn't be picked out just by a value comparison. Last note on diffdf is you can match on keys rather than row number. This is very useful for us in practice because usually we don't care about the sorting of the data set, and normally it's much easier to use a unique identifier to examine the object instead. So in conclusion, this is still an ongoing effort, but we've had some successes. I have someone who has used SAS for 30 years, who would never want to use R, and now can't stop talking about the tidyverse. So I definitely think tidyverse is a great way to convert people. And yeah, my one last note is that it's really easy to make a package in R. It doesn't have to be big, it doesn't have to be complicated. It can solve one problem, and it can solve one problem well. Thank you very much.
I guess we have a few seconds to chit-chat. Who here is French? You guys, do you know what pastis is, the drink? So of the French people, do you like it? No? Disgusting? Who thinks it's disgusting? Oh, come on. I think it's pretty amazing. So this is the next talk in the series on industries that are resistant to change. So I see your pharmaceutical companies, and I'll raise you actuaries and the insurance industry. So the main thesis is that we want to get insurance folks together to do a few things, to conduct practical apply AI research in the open, create software to implement those ideas, and also develop education material to democratize this new knowledge. So insurance companies have a lot of common problems that they share, and it would make a whole lot of sense, if they actually got together and solved those problems so they can focus on their own problems and own data, and that's where the competitive advantage really lies. So actuaries like to say, okay, machine learning models are totally black box, we can never use them because we're heavily regulated. But as we know, there have been quite a few advances in model interpretability lately, partial dependence plots and friends, and there are packages to implement those techniques. So maybe it's about time we introduce those. And if you wanted to find tutorials online for data science, machine learning, you can find basically everything. You want to classify cats, you got it. If you want to, make people naked in their pictures, you can do that too. But then people would kind of struggle to find really good material for actual modeling. So the idea really is to solve the common problems together, so we have more resources to focus on our own unique problems. And we're going to do that by getting together actuaries, data scientists, engineers, claims analytics professionals, lines of business leaders, and collaborate through platforms that are tried and true from software engineering, but also have been already adopted by many industries. So with that, I would like to invite you, if you're at all interested in insurance, to participate in Casa AI, which is a open source community that's dedicated to moving the field forward. And I want to give a shout out to the other open source communities that we drew inspiration from. So you're familiar with our OpenSci and Bioconductor, and Oasis is a catastrophe modeling platform that is open source and has been gaining traction lately. So you have concerns, of course you do. So what are some of the obstacles? So for one, we have to have a conversation around the culture of sharing and intellectual property. And that's going to take a little bit of time to get through to the industry. And we want to bridge the skills gap for Excel users, which most actuaries and insurance professionals are, so that they can participate in coding and learning about reproducibility. And of course, the value proposition to contribute to open source in this industry is not very clear for the individuals. So there's going to be some education around that also. So in this last minutes, we'll focus on resources in particular. So we've come to terms with the fact that it's really hard to sustain open source projects with just nights and weekends from occasional nights and weekends from a few individuals. So in the coming months, we're going to be more proactive in establishing partnerships and relationships with actuarial societies, companies, academic labs, and whatnot. So if you or your organization is interested in partnering, pull requests are always welcome. But if you are interested in sponsoring people, definitely get in touch. So there's a website. We also have a blog, which hopefully will have some more new content in the near future. And again, if you're interested in any of this, please reach out. Thank you.
Hello, my name is Alexander Kowarik from Statistics Austria, and I also work in the industry, or not in the industry, but in an area which is a bit hesitant to adapt R, so that's official statistics. And I want to talk about two things that we do to try to introduce R more into the world of official statistics, and one R package at the end. So the first one is UROS. It's the use of R in official statistics conference, and it exists since 2013. It was started by the Romanian colleagues, and it ties together the R community in official statistics. And we reached now about 100 participants in the last 2 incarnations. And the next one will be in May 2020. I think it's the 6th to 8th, if I'm not mistaken, in Vienna, hosted by Statistics Austria. So if anybody is interested in official statistics, so that means survey methodology, time series, statistical disclosure control, these are issues there. And what we started in 2018 in The Hague as a side event is an Unconf UROS, so you might know the Unconf. We try to tackle problems we face in official statistics together. So we collect ideas beforehand, so participants or basically all interested R users from official statistics, or not even R users, can write an idea proposal, and the prototype should be doable in 1 to 2 days. So that's the time frame we have for the work. And one example is that a Canadian colleague, Manolo, saw the picture of this artist, the German NSI, on the homepage and asked if it's easy to do that in R. So it was not easy to do that in R at that point in time. So we built a team, so one colleague of Statistics Austria and myself, and we looked around, and fortunately there's a D3 plugin which does a thing that looks quite similar to that. So it's a Voronoi tree map. And there's an R package, HTML widgets, which makes it really easy to use that from R and to create a plot like that from R. So in the 2 days, it was in 2018 in The Hague, in the Unconf UROS in The Hague, we created the R package Voronoi tree maps. It's already on CRUN since, I don't know, a year or so. And there are just a few functions in there. Basically, you take your data frame containing the hierarchy, so there's some kind of hierarchy displayed in the plot. You export it to JSON and then you send it to D3. And there's also a small Shiny app where you can change a little bit the settings. So if you see the plot, so we saw before we had some kind of hierarchy. So in this example, it's a GDP. So the coloring is according to the continents, and then inside the continents we have the countries. And the size of the Voronoi slices is the actual GDP value. There are, of course, a couple of settings from where you can change from R the behavior of the JavaScript afterwards. So you can change borders, colors, you can switch on a legend. Then we had the problem that if you want to use that on our homepage, it should be the same if we generate it again. And if you set the seed in R, it doesn't help because the random part is in JavaScript. Then we looked around again and found the seed random JavaScript library. So somebody else also had the problem and solved it, and we used that as well. Yeah, you can change more colors, so you can set all the colors independently, and you can change the size, of course. So the idea is that you can plug it into your homepage or your NSI homepages. You can change the colors also according to some scale. You can use the scale package for that, so that the information of the coloring is not like a continent like before, but also according to another value and not the value you used for size, that you have more information in the one plot. And the last thing, you are all invited to join us in 2020 in Vienna. And also, if you want to collaborate on projects in the area of official statistics, go on our GitHub page and you find information already there a little bit. Thank you.
Hello, I come from the official statistics area myself. I work for the Office for National Statistics in the UK. a major provider, producer, publisher of official statistics, and through various social and business surveys. And my talk is about an R implementation of business survey. We used R for that. So to begin with, there's some traditional approaches to survey inference, like the expansion estimator model assisted approach with using auxiliary information. They are straightforward, well-understood properties and available in survey and regenesis R packages. But with our new introduced survey, which tries to measure the annual service turnover of UK service sector businesses with over 2,000 service products to be questioned, and the outputs are really important and used, for example, for the as input to GDP. So this is a case where we have plotted the registered employment of these businesses against a particular service product. As we can see, this red line is not actually lines, lots of zeros, which because businesses do not offer all the products available according to their industry sector. And when we try to fit an expansion line, the black one, or a ratio, we can see that the zeros drag down, and we cannot explain the variation well enough. For this reason, we chose to implement a model-based approach, which is actually a two-part conditional ratio. The first part is to estimate the probability that the business provides a particular service, and then model the service turnover. And the estimator looks simple as this, but it's not, with one part as the sample part and the unsampled estimation of the sample businesses. Using R, we created some custom functions to estimate all of these parameters and the measures of accuracy. And I'm saying successive function because outputs were used as inputs to other functions. It was easier to track calculation, and this is roughly the pipeline that was created, beginning with data preparation, the propensities calculation, which is the probabilities of making a product, the main body with the calculation of all the parameters, and finally the final output contains in a nice tidy format all the information we want, and of course the estimates. These are some code examples of the data preparation stage where we use the tidyverse functions. We want our data sets that are used in the pipeline to have a certain format. We want to create some variables, and then to be put in a function like this. This particular function calculates the slopes of the industry and service product pairs, which we estimate. We're using tidy format. And regarding the results, we wanted to compare with previous methods. Here, this scatter plot compares the standard errors of the model-based estimator with the expansion, and adding a quality line, we can see where most of the points lie. And here, again, by grouping according to sample size of the non-zero responses, and we can see the more information we have, the more sample size, the model-based estimator has smaller standard errors than the expansion estimator. And finally, confirming that with another scatter plot of the log ratio of the standard errors of these two methods against, again, of the number of non-zero responses. And we can see as we move on with more sample size, model-based is more efficient. So that was our conclusion, and again, R offered us the versatility and speed to handle large amount of data and calculations, and with all these several functional procedures were created, contributing to our office's transition towards open software. Thank you very much.
Everyone, thank you. I need a transition. Okay, here's me. So I apologize for those of you who don't know what genomics is. I realize it's quite different. It's been a very diverse session. You can look at it as mutations in DNA that can be a cause or a consequence of a disease, just to give you a very brief summary before I start. Okay, so I am Roxane Legai. I'm the lead clinical bioinformatician at the Peter MacCallum Cancer Centre in Melbourne, Australia. And today I would like to show you a little bit how we've been using advanced R packages for the visualization of clinical data in a cancer hospital setting. So I thought I would spare 20 seconds of my short talk to show you the amazing place where we live and we work. So for those who don't know, Melbourne is the southeast coast of Australia. It's a terrific city, it's gorgeous, it's awesome. And on the other side there is a building where we work, the Peter Mac, or also called VCCC. And I would really recommend you come and visit. Okay, so I work in the pathology department, and we provide a next-generation sequencing service. So basically, we take the blood from the cancer patients, extract the DNA, analyze it through those machines called sequencers, then it goes through bioinformatics pipelines that have been developed in-house on big computers, and then the results are loaded in this tool you can see there, which is a curation database called PATHOS. Then from there, the clinicians look at the results, and based on the mutation profile of the patients, they can make decisions on what treatment is the most appropriate for them. It can be chemotherapy, radiation therapy, immunotherapy, or in some cases, no therapy at all is actually better. Okay, so one way of using R and some packages to look at the data that we have in our databases is to use ggplot. So this is a simple way for us to track how we are doing with the number of cases we see per month. So we provide assays called gene panels, which are sequencing assays. And so what we can do here is that we look at how many cases we have per month, depending on which panels we're looking at. So what I can see here is that my somatic panel has been in use for a long time, and we have hundreds of cases per month. And now we are starting to see this growth of the comprehensive cancer panel and the pan-heme panels. And those ones are specifically designed for blood cancers and solid tumors. Now, if we dive a little bit deeper into the actual genomics findings that we have in our database, I use a package called OncoPlots, where I can look at the actual variance types in our assay. Here I'm looking at data from the somatic panel. What I see is that I've got mostly missense mutation in my data, this green thing there, which makes sense because I also see next to that most of them are actually SNPs, which means just normal polymorphism like between you and I. However, I can see that there are a smaller number of insertions, deletions, nonsense mutations, frame shifts, splice site mutations, and those are usually mutations that can be relevant clinically and also actionable. Same thing with the type of SNPs that we have on the right there. Most of them are C2Ts, which is quite common. However, we've got a smaller number of other type of changes that can be more relevant for us. And on the bottom right corner there, what I see is the top 10 most mutated genes in my assay and in my cohort of patients. And without surprise here, we see that TP53, hoping you can read, is the most mutated gene. As you may know, TP53 is really well known to be involved in a lot of cancers, so it's not surprising for us. This is the actual OncoPlot or waterfall plot. And what you can see is that per row, you have a gene, and then per column, you have a group of patients that follow this profile, mutation profile. So for instance, in our cohort, we can see that half of the patients have some sort of mutation in TP53, and the other half doesn't. Then within each of those subgroups, some of them have also a mutation in KRAS, for instance, which is a gene known to be involved in lung and colorectal cancer. So that will help us with the diagnostic of the disease to start with. And so on with ERBB2, which is more for breast cancer. So each of those genes and those mutations, or some of them, have an actual treatment that has been targeted especially for them. So it really helps us to know where our patients sit in this profile, so we can actually provide them better treatment and advise on therapy. And finally, another way to look at it is to use ggplot as well to look at the pathogenicity of the variants in our database. So for instance, here is a pan-heme panel on the left side, the first one here. Obviously, again, TP53 is the gene with the most mutations in there. I can see that about a fifth of them, in gray, are unclassified. So we don't know if they are pathogenic or not. We actually don't know much about them. Then we've got another fifth which are not pathogenic. So we know that those ones, they are not involved in your cancer. And then, of course, the vast majority of them are pathogenic. And that's the ones that we might try to target to help the patients. And that's it for me. You can contact me by my email. You can find me on LinkedIn. And I'm going to do a quick self-promotion. In October, I will be running 7 kilometers to help raise funds for the fight against cancer. So if you'd like to visit my page and make a little donation, that would be awesome. Thank you.